Hello and welcome to the fourth lecture of our Foundation Model Week. In this lecture we're going to talk about using embeddings with large language models. And I'd like for today's lecture to thank contributions from Maciek Pankowitz, Andre Zambrano, and Rachel Liu. So as I mentioned in the last lecture, most of the use of large language models in our field is prompt engineering. But prompt engineering isn't a particularly optimal way to add information into the large language model's knowledge base. I mean, sure, you can just append all the info to the beginning of your prompt. A lot of these tools now have really large context windows, but that's clunky, expensive, and it doesn't always produce the best results because after a certain scope it leads to forgetting. An alternative is adding information to the large language model's knowledge base through embeddings. And embeddings are the first step, in fact, of how a large language model works with text. What you do is you take the text and you convert it to an embedding. An embedding is a multidimensional vector of numbers. Each token, usually word, in the text is converted to a multidimensional vector by a neural network. And each dimension of the multidimensional space represents some aspect of the semantic or syntactic properties of the token. For example, the first one might represent a verb, the second one a mammal, the fourth one a valence, the sixth one attitude towards bananas. Now, I'm not saying that ChatGPT has a specific dimension for attitudes towards bananas, but the frank truth is we don't actually know what any of its dimensions mean. Now, embeddings are not new to the current generation of large language models. In fact, the first major embedding approach was Word2Vec from 2013, which was based on a neural network approach, but was much, much simpler than GPT's embeddings. Most large language models out there have publicly available tools for transforming tokens, words, into embeddings. And you can add those embeddings into the large language model's knowledge base. And this is a fast way to give the large language model additional information that it treats as its own knowledge when you use it. It's like downloading information into somebody's brain, exactly how kids don't learn. You can store those embeddings locally or embed them into the large language model's knowledge base. You might want to store them locally in order to search through them and decide which ones you want to add to the LLM's knowledge base in a specific situation to have it ready, kind of present at mind. There are many use cases of embeddings within educational data mining and learning analytics. For example, they can be used to provide key info to the LLM for use in generating responses. For example, that is seen in our GPTA project at the University of Pennsylvania, where we provide past forum responses and grading feedback from the instructor to the LLM to use as examples when it responds on the forum and provides grading feedback. For example, in this example, we've fed the LLM information about the variables, the columns, in a data set that the student is working with in an assignment, and the student can ask questions about it, and GPTA can give meaningful feedback. Embeddings can also be used to transform text into a representation that can be compared to other text representations in terms of distance. And this has a lot of applications for selecting which text is most relevant. For example, Schneider et al. Used it to determine which reference answer a student answers closest to. Other folks have used it to cluster mathematics word problems or course descriptions. Wang et al. And Surawachet et al. Have used it to classify text into categories. Folks have used it for outlier detection. Lots of applications. Embeddings can also be used to transform text into representation that doesn't even need to be used in a large language model. It can be used as features in models predicting other constructs. So, we can now transform text into very high-quality multidimensional representations, and there's lots of uses. There aren't many citation examples yet in EDM Learning Analytics as of this recording, but I feel very confident that the next edition of this course is going to have a bunch of these examples. In our next lecture, we'll do a deep dive on a third method using fine-tuning.